Hello everyone and welcome back to Geminic Science. In this tutorial we're going to be looking at the pentose phosphate pathway, which is also known as the PPP, and this is what stands for the pentose phosphate pathway, and you can also call it the hexose monophosphate shunt. Let's break it down step by step so that you can understand everything easily and clearly. Notice that the pentose phosphate pathway is an alternative pathway of glucose metabolism, and this does not produce ATP, but it generates the NADPH and the ribose 5-phosphate. Notice that the NADPH actually is an essential for biosynthesis reaction and protecting the cell from oxidative damage, while the ribose 5-phosphate is necessary for nucleotide and DNA synthesis. Notice that the first stage of the pentose phosphate pathway is the oxidative phase, where we have glucose 6-phosphate, which is converted into the ribose 5-phosphate. Let's take a very quick revision on our glycolysis. Remember on our previous video on the overview of the glycolysis, which we used this mnemonic, we said good, girl, friend. I'm going to stop here because that is just what I need for today. Which we said, actually from the definition, we said the glycolysis is simply the breakdown of glucose. So the good actually stands for the glucose. Then the girl stands for glucose 6-phosphate. Then when it moves down, we have the friend, which is fructose 6-phosphate. So as this process is moving from glucose 6-phosphate, instead of it to continue down to fructose 6-phosphate, it diverts and changes another direction. And that is how we found the PPP, which is the pentose phosphate pathway, or the hexose monophosphate shunt. Let's clean this and write it nicely. The first thing I need you to keep at the back of your mind is this. The pentose phosphate pathway actually occurs near the beginning of glycolysis. Remember, glycolysis is simply the breakdown of glucose into the pyruvate. And if you could remember, we said glucose actually is a 6-carbon molecule, and it has to split into 2. 6 divided by 2, which is simply going to be 3. And the final product at this point is going to be the pyruvate, meaning pyruvate is 3-carbon molecule. So back into our main topic, which is the pentose phosphate pathway. So let's assume we have glucose, which is the girl, which breaks down into glucose 6-phosphate. The friend, which is going to be the fructose 6-phosphate. And at this point, sorry, let me put it down a little bit. And remember, we said it actually happened from glucose 6-phosphate. Instead of it to go down and continue into the circulation, then this will form another pathway, which we call the PPP pathway. And notice that this diversion here actually happened by these enzymes, which I'm going to write in green. glucose phosphate dehydrogenase. Glucose phosphate, then dehydrogenase. Alright, let's begin from here. Let's take out all this. Let's say here we have our glucose 6-phosphate. To make it easier for the second step, the only thing that will be added is going to be 1,5 lactone. Let me show you how it works. So, meaning that we are going to bring back our glucose. Glucose is going to be glucose. Then we'll put dash 1,5 lactone. Then bring back our 6, then phosphate. Okay, now let's write it. The next step at this point, we said is the addition of 1,5 lactone. Glucose 1,5 lactone 6-phosphate. And notice that this conversion actually happened with the help of an enzyme glucose 6-phosphate dehydrogenase. And in this process, the molecule of NADP plus is going to reduce into NADPH. And once you have the glucose 1,5 lactone 6-phosphate, at this point it can then further be converted into the 6-phosphogluconate. But to make it easier, how do we get the 6-phosphogluconate? So we have the phosphate at the end by our right hand side, and then gluconate, taking this one to be the first one, then here the second one, then this one should be the third one, but you have to put it in the beginning. So here is going to be 6-phosphogluconate. By which of the enzymes? Here is the enzyme, which is 6-phosphogluconolactonase. And this is what hydrolyzes the glucose 1,5 lactone 6-phosphate into 6-phosphogluconate. For our next step, we have this important enzyme, which you find here, which is called the 6-phosphogluconate dehydrogenase. 6-phosphogluconate dehydrogenase, write it in short form, D. That is for the dehydrogenase actually. What this enzyme does, it simply just decarboxylates the 6-phosphogluconate here and convert it into the ribulose 5-phosphate. To convert it into ribulose 5-phosphate. Another molecule of Na, and at this point another molecule of NADPH is going to produce. But remember, okay, let's put it this way. We have, throughout this pentose part, we are going to have two production of NADPH. At what stages? Stage number 1, and I think it should be 3. So at this point, NADP plus is going to be reduced to NADPH. So once we have the ribulose 5-phosphate Notice that the ribulose 5-phosphate can actually do some couple of things. One, it can be converted into xylulose 5-phosphate. Or it can also be converted into ribose 5-phosphate. And these two things that happen here, actually, it takes place with the help of different enzymes. For the ribose 5-phosphate, it's being converted by the help of these enzymes, which we call the isomerase. And the conversion of ribulose 5-phosphate into the xylulose takes place with the help of these enzymes, which is the epimerase. Notice that the xylulose 5-phosphate which you have here can now be redirected back into the glycolysis. Here we're going to have our transketolase. And this actually acts again by transferring 2 carbon units. That is from the xylulose. From the xylulose 5-phosphate. It will transfer this back into what we call the erythrose 4-phosphate. And this is what will form the fructose 6-phosphate. And here we have gone back out into our glycolysis. What about the right hand side, which is the ribose 5-phosphate? So notice the ribose 5-phosphate here can now be converted into what we call the PRPP, also known as, is going to be the 5-phosphoribosyl 1-pyrophosphate. And notice that this is a very important molecule which can now be redirected into pyrimidine or purine. So this is what I got for you for the pentose phosphate pathway. I hope you find it very helpful. Please just do me a favor by clicking on the subscribe button, also like and share. I'm also going to drop a link down below in the description section on the process of glycolysis, and we have the Krebs cycle, which is the citric acid cycle, and which one again? I don't know. I'm going to check if there is any other one which I can join them together. Thank you for watching and see you in a... Hello everyone and welcome back to Gemnix.